Hi there, exercise 3F.2. We looked at a guy with a paper bag on his head disguising himself, and we've got another guy here. Did more disguised quadratics. That's what we're looking at. We're just trying to practice our skills with normal quadratic equations and extend them. And I suppose this is the difference between A-level and GCSE. We expect these to be a bit more tricky at A-level because, otherwise what's the difference? So they are quadratic equations, but they're definitely not as obvious as you would get at GCSE. Let's have a look. So here's our standard example, I've called it. So, okay, let's have a go. So 2x to the 2/3 minus 5. So you can see, if you remember last time, we talked about as long as this power can be doubled and gets this power, whereas this has got no power, then it's the disguised quadratic. And you then write this middle thing as what you're looking at, y equals x to the 3rd. And if y equals x to the 3rd, I can now write 2y squared minus 5y minus 3 equals 0. And from there, I can then solve it. So I chuck that into my calculator, and that's fine. You're allowed to do this. So again, press the mode button, get yourself in the right mode. So I've done it, yes. And then type in your ABC. So I've got 2, I've got negative 5, and I've got negative 3. And I've got answers, I've got 3, so I write y equals 3. And my second answer says minus a half. Y equals minus a half. Now last time we've got a negative, we had problems, but this one won't be a problem. Because last time we had x squared, so therefore we had to square root our answer. But this time it says x to the 3rd equals 3, and x to the 3rd equals minus a half. Now that's not such a problem. If I move that 3rd power over, it actually becomes a cube. It becomes x equals the 3, and that becomes 3 cubed. Or in this one, x equals minus a half cubed. Now, that is 27. And this one is, if you do minus a half times minus a half times minus a half, you get minus an 8. So that's my two answers. Let's see what I get here. 27 and minus an 8. So they're relatively straightforward, but you just got to do the right thing at the end. So on the last PowerPoint we were looking at, we always had like a square root thing here, or a squared, sorry, and then before we had square root. This time we've got this x to the cubed, so therefore it's a different operation when you move it over. This time it becomes a cubed, and therefore there's our answers. Let's have a look at this one. This is solving this simple exponentials, but notice we've got a power. This is double the power. It says 2 to the 2x. It says 2 to the x. So the power is definitely doubled. So what do I write? I write y equals, the middle one, is 2 to the x. And therefore I can write this as y squared minus 10y plus 16 equals 0. And I need to solve the equation. So again, chuck it into your calculator. I've got 1, I've got negative 10, I've got 16, it's all gone in my calculator, and my answers, according to me, I'm sure I could have factorised this myself, but I didn't bother. I just got a calculator to do it. I got y equals 8, and I got y equals 2. So clearly you could have done it yourself, but of course now we don't leave it as y, we write this 2 to the x equals 8, and 2 to the x equals 2. Now this relies on us being able to move effectively this power thing onto the other side. There is a method later on, with really difficult ones you can do it with, but at the moment we can just look at it and say, hang on a bit, this is really just a case of 2 to the x is equal to 8, but what is 8 as a power? And you should be able to think to yourself, well, 2 to the x then, I need to write 8 as 2 to the something. And you think 2 times 2 times 2 is 8, so it's 2 to the 3, and therefore x is equal to 3. So this ability to think of 8 as 2 to the power of something allows us to solve it. And I'm only doing it because it says 2 to the power on the left. If it said 3 to the power, I'd be thinking, what's 3 times 3? What times 3 times 3? This one's a lot easier. This 2 to the x, 2 can be written as 2 to the 1, because 2 to the 1 is 2. So therefore the x equals 2. X equals 1, you got it wrong then. And notice you just equate the powers when you do that. X equals 1, x equals 3, so it worked. So, another one here. So what have we got? Very similar indeed. I should point out that sometimes these are written slightly differently. So because it's 3 times 3 to the 2x, this could have been written as 3 to the 2x plus 1 minus 3 to the x minus 24 equals 0. So I'm not changing this because you should remember that if you have powers, there's a 3 to the 1, you see. And when you times powers together, can you see how you add the powers? That's the rule. Times powers together, you add the powers. And that's what I did. I wrote 3 to the 2x plus 1. Now, if they give you this as their starting question, you need to spot that that means 3 times 3 to the 2x. And I suppose the clue is we expect in this to be doubling. So we're thinking, well, I need to have a 3 to the x. I've got that. This needs to be 3 to the 2x. I've got 3 to the 2x plus 1, and therefore I better put the 3 in the front. Now the good news is here, we didn't have to do any of that. They wrote it in a nice fashion for us. But I'm a little bit concerned. Perhaps you will get ones like this, and therefore you'll need to be thinking a bit more clearly about that. Anyway, they've been kind. They've written it like this. I'll start by writing my y is the middle one. That's 3 to the x. And therefore my equation, because they've been kind, I know it means 3y squared minus y minus 24 equals 0. Let's get our calculator out. Type those in. I've got 3 for the A, I've got negative 1 for the B, and I've got negative 24 for the C. And it quite simply says that y is equal to 3 is one solution. Well, it says x1, but I know it's y. And the other one's a bit yuckier. Presumably this does factorize if I'd chosen to do it by the factorism route. But y is minus 8/3. Okay then, so that, what is that? That's 3 to the x really, because y is 3 to the x. So 3 to the x equals 3. Or 3 to the x is minus 8/3. It's not quite so pretty, that, is it? Have I typed that in right? I suspect I have. We'll find out in a bit, I suppose, when we look at the answers. This one is x equals 1. This is fine. But this one is not quite so nice. And we've got to say to ourselves, well, I mean, you could like this one I knew because it says 3 to the x is 3 to the 1. So really what I want to do is I want to be able to write this to 3 to the something. That's what I'm after. Now, to be honest, I think I'm going to be saved because that negative is going to save me. I should point out why it's going to save me. And it's going to save me because otherwise I would have had to use another technique called logarithms to solve this. The reason why it saves me, because if I draw the graph of 3 to the x, this is the graph of y equals 3 to the x. Basically, 3 to the power of anything, 3 to the power of, say, 1 is 3. 3 to the power of 0, well, that's actually 1. Dodgy scale going up here, but you get the idea. 2, 3 to the power of 2, 3 to the 2 is 9. So, very dodgy scale going up here. But you see the basic idea. If I put in 3 to the power of anything, even a negative number, the answer is always positive. So our question here is, when is 3 to the x equal to minus 8/3? And minus 8/3 is down here somewhere. Well, the answer is never. So, in fact, this is, we're never going to solve that. So we write no real solutions again. Now, it's a slightly different reason this time. We write since, and because it's 3 to the x, we write 3 to the x is greater than 0 for all values of x. And it can't be equal to 0 even, because it's never ever touches this line. It's always actually positive. So I actually only get one solution on this. I get x is 1. And that's, luckily, x is 1. Now, we're going to go on then in class to do the remaining questions from question 1 and then all the others. But I would perhaps take this opportunity to perhaps pick a couple of weird ones, and I'm going to solve, say, this one. These are the ones I asked you to do as an extension last time, but you might not have got onto them, so I'll just do it now. So if I do this one, x minus 8 root x plus 13 equals 0. Definitely, if I think of this as x to the half, you can see, and this one's x to the 1. It's definitely a disguised quadratic. I've doubled the power. So I'm going to write y equals the root x. And therefore I've got, well, what have I got? I've got y squared minus 8y plus 13 equals 0. It's not very nice, that. It's not a nice equation. Not on first glance. There, I'm going to type it in. 1, negative 8, and 13. It gives me horrid numbers. Look, it gives me y equals 4 plus root 3. Y equals 4 minus root 3. They're my two solutions. How cool is that? But notice it's not really y, it's root x. So therefore root x is 4 plus root 3. Or root x is 4 minus root 3. So I've got to... The reason why I chose this one is because a lot of the examples we saw initially were like this, where we ended up square rooting the answer because we ended up with an x squared thing or an x squared thing here. So we end up square rooting, but this one's already got the square root. So if I move that square root on the other side, x is 4 plus root 3 squared. Or x is 4 minus root 3 squared. Now I could work that out just quite simply, but I'm just, fundamentally quite lazy. So I'm going to get my calculator. I'm going to type in 4 plus root 3, close my bracket. Oops, type it in right, always helps. Move it over, now close my bracket, squared, and that gives me 19 plus 8 root 3. And again, I can quite easily go back to that and tell it to do it for 4 minus root 3 instead. And it says 19 minus root 3, so I could even write a little minus there, it's the same thing. So, not as usual as the type we've seen so far, but definitely one that I recommend us getting used to the fact that you've got these different varieties of questions that we want to be able to solve. And interesting, you can see there 19 plus or minus 8 root 3. That was the answers the exam board wanted that year. So hopefully that makes sense. We're going to go on to exercise 3F again, and in class hopefully finish that exercise. So hopefully that makes sense.